surface changes. Ethane becomes ethanol, propane becomes propanol, butane becomes butanol, hexane becomes hexanol. Then when you have the alkanone functional group, another name for the alkanone is the ketones. What do I call it? Ketones. Alkanone are also known as what? Ketones. Ketones. Why this one are known as alkanals? Aldehyde. So they can be used interchangeably. Whether they call it alkanals or they call it aldehyde. Alkanones, ketones. Now when an alkane has the surface, the functional group of the ketones, the surface changes. If it's ethane, it becomes ethanol. If it's propane, it becomes propanol. By the time it has the functional group of the ketones, it becomes propanol. Butane becomes butanol. Hexane becomes hexanol. So it's the surface that changes based on the functional group in that compound. Are you hearing me? So go and master your first 10 alkane homologous series. Pentane becomes pentanol. Then let's look at their general formula. The general formula for the aldehyde is CnH2n plus 1CHO. This is the functional group for the aldehyde. Then the general formula for the alkanones or ketones is CnH2n plus 1CO. If you check, what is common between them is the CO. They both have CO. That's what makes them a carbonyl compound. Then the difference is that the aldehyde has hydrogen attached to the functional group, while the ketones, they only have CO. The another difference is that, or the quick way of recognizing them, when you see a compound, how to know this is an aldehyde, how to know this is a ketone. The aldehyde, their functional group is always found at the end of the compound. When you draw the structure, you always see it at the end. Now this is an aldehyde. You can see the functional group at the end. Then this is a ketone. The functional group is in between. So ketones are always found in between carbons. That's why you always hear butan 2O, butan 3O. Are you getting it? You can't find carbonyl compounds, the ketones at the end. The ketones are always at the middle.